So now let's talk about the rules of IUPAC naming. So we have got two main rules, and under those rules we've got a lot of explanation, but let's talk about the two main rules first. So the first rule right here, first rule right here is the selection of the longest chain. So if you remember from like a few minutes ago, the root word talks about the number of carbons present in the longest or in the parent chain. This parent chain is called basically the definition of a parent chain is the longest chain in the compound. So that's the selection of that is one of the rules present in the IUPAC naming system. So we've got a few rules to take care of. And the first part is that it should be the longest continuous carbon chain. So the longest continuous carbon chain. And it should be a chain, if there are, multiple chains of the same length and they are the longest, then the next thing you should check for is the one with more substituents. So more substituents. And also you should check any functional groups. Functional groups or multiple bonds like double bonds or triple bonds. So those are the things that you have to check for when you're selecting the longest chain or the parent chain. So the parent chain is the one which is the longest, and if there are many chains of the same length, like 5 carbons, there are many chains present in the compound, each of 5 carbons, and 5 carbons is the longest chain, then you have to check for the substituents or functional groups or the double and triple bonds. Now, the order of importance here, suppose there are two 5-membered 5-carbon chains present in the compound, and in one of the compounds you have one of the chains you have a functional group like OH, which is alcohol, and in the other chain you have a substituent, which is chloro or chlorine. Now here, this is a functional group, and this is a substituent. So in this case, you would give more preference for the longest parent chain with the one that has a functional group. So our order of importance here, let's see. So the order of importance here is very important. Actually, that sounds really nice. So you would give more preference for a functional group, then a multiple bond, and then a substituent. So that's very important to keep in mind. This determines a lot of things. So that's very important. Now, we could go with some examples for that. Let's go to the side here. Okay, so here we are with a problem. So I want you to try and figure out what could the parent chain be. And you can pause the video to figure it out. Okay, so I'm assuming that you paused the video, but let's find out what the parent chain is. So I'm going to use a different color. Okay, so let's see, just by eyeballing it, we'll find out what you think is the longest carbon chain. So there's one here, 2, okay, let's put numbers. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's an 8-membered chain. But we've also got 1, 2, 3, 4, 5, 6, 7, 8. So there's another 8-membered chain. And we've also got this too. There's no space anymore. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Now, these are 3 possibilities that we're looking at, and all 3 of these possibilities have an 8-membered carbon chain. So, of these 3 possibilities, 2 of them are identical. Can you figure out which 2 they are? That's right. The 2 that are identical are the yellow and the green ones. So, these 2 right here. Because they both have one methyl substituent. As we've discussed in a previous video, this automatically means CH3 when there's no, no element mentioned means hydrogen. So, yeah. Anyway, so the yellow and the green numbered chains are the same, or not, yeah, they're identical. Now, so we could just consider these 2 as one, and this as another one. So out of those 2 possibilities, which one would you prefer for your IUPAC naming? That's right, we choose the second option. Why is that? Okay, so let's look at the chain. So I'm going to highlight the chains and you can make an observation. So let's start off with the red chain. This is our red chain. So on the red chain, you only have one substituent or branching out group. This is a substituent for the red chain. Now, if we were to go with the yellow chain, let's see. With the yellow chain, which is this, straight down, here you'll see that actually there's one substituent here and one substituent here. Now, if there's more substituents, that means there's more branching. So when you're looking for an IUPAC name, you usually look for more branching. Branching is very important when you're looking for an IUPAC name. More substituents means more preference for that chain, which basically means more branching means more preference for that chain. Now, similarly, if we look at the green chain, you would get the same thing, which is this. So once again, okay, not once again, you would have this and this as the substituents. But either way, they have the same amount of branching, which is why either one doesn't matter. They're both identical in this case. So yeah, that's that example right there. You could try out some other examples on your own. So let's get to the next rule. So now we've got the lowest locant set rule. And this rule basically talks about the numbering of carbons in that chain. So once we've found out what the longest chain is, the numbering of the carbons in that chain also matters, because based on the numbers, the position of our functional groups can be determined, or can be represented, so that other people can understand what we're talking about. So this is also very important. And we usually number the carbons in the parent chain so as to give the lowest possible locant. Oh, also the number that we give to that carbon is called a locant. So if, let's say that this is a carbon chain that we have right here, and we're giving it some numbers, 1, 2, 3, or 4. These numbers that we're giving to the carbon are called locants. Pretty much in its name, it's giving us the location of a group, whether it's a substituent or a multiple bond or a functional group. These positions are told to us by locants. So yeah, that's the importance of a locant. Now, if we were to discuss how a locant is given to a chain, we usually look at the priority order that we have here. This same priority order, which is functional group, greater than multiple bond, greater than substituent. We look at the same priority order when we're giving locants. And when we're giving locants, we have to give the same priority order. So, I don't really know how else to explain this to you other than example, so we're going to go with an example, okay? So we've got a compound right here. I'm going to draw this in black. So we've got that, and let's just say that we have a chlorine here. Now, what is chlorine here? Chlorine is a substituent, okay? But we're going to discuss this small example here first and then get into detail later. So if we're going with this right here, we've got two ways to number this compound or give locants to this compound. So one of them is this, 1, 2, 3, 4, 5. Okay, let's put these all under. 5, 6. This is one way. And the second way is by doing this, the other way. 1, 2, 3, 4, 5, 6. Now, according to the lowest locant set rule, we have to give the lowest locant. It's pretty much in the thing. But the lowest locant should be given in this priority, right? Now, since we don't have any of them except a substituent, we'll just give the lowest one to the substituent. So in this case, what is the lowest possible locant for that substituent? We've got 2 or 5. No, obviously 2 is less than 5. So 2 is the lowest locant here, and therefore we give the blue order, or the blue locants are correct. So yeah, that's what we get with that. The blue locants are correct. Now let's go with another example, preferably one with, both of them. Oh, yeah, both of them. Actually, I was thinking that we could give a name to this. This compound will be named as 2-chloropentane. Sorry, not pentane. Hexane. I didn't count my carbons correctly, but yeah. So as we've discussed earlier, we're using since there are no double or triple bonds, we're using ane. Since there are 6 carbons, we're using hex. And since there is a chloro group, we're using this. It's pretty straightforward. When you're mentioning the substituents or whatnot, you also have to put the locant in front. But yeah. So there are some things that I want to talk to you about when it comes to the rules of IUPAC naming, and some of them are, things to keep in mind. So the first thing is, when there are different branches present in your compound, arrange these branches in your IUPAC name in the order of, alphabets. So when you're naming them, make sure to use an alphabetical order. So use alphabetical order. When you're arranging the groups in, your name. And also, another thing to keep in mind is that when you're having multiple of a similar substituent, then we have to use some specific, terminology for this. So when we're having multiple of the same substituent, I'm using shorthands here. Then if there are two, then we have to use di. 3 would be tri. 4 is tetra. And so on. Now, this is for a smaller substituent, like chlorine, or chloro, bromo, methyl, and whatnot. Now, if we're having like a big substituent, for example, you could have phenyl rings attached. This could be a substituent. Now, these are big substituents. Now, for this terminology, we would use something else. So this would be bis for 2. 3 would be tris. 4 tetrakis, and so on. These could be, available to you on the internet. Usually, you won't really have to go more than 4. But yeah, these are some things that I want to mention to you because they also come in handy when you're doing IUPAC naming. Another thing that I want to mention, especially about the first rule that we have, that is that even if, like, how do I describe this? Okay, see. Even though there are 2 chains, suppose there are 2 chains present in your compound. One is the longest, but doesn't have any substituents or any branching or any multiple bonds or any functional groups. There's nothing, just the fact that it's the longest. But there's also another chain present in the compound but has multiple bonds or substituents or, functional groups. Now, when that comes around, you have to choose the one with more groups attached to it, because that's our parent chain. The whole point of the parent chain is for it to have more substituents. Although you have to look for the longest continuous carbon chain, the substituents, functional groups, and double bond, triple bonds also matter equally. So that's why, just remember that. So the length of the chain may not be the deciding factor for a parent chain. So yeah, that's just something that I want to put out there. All of these points, like those last minute points, can help you, especially when you're dealing with bigger compounds and with more functional groups.